What if everything you think you know about the birth of the universe is wrong? It wasn't a bang, an explosion, or the beginning of a place. It was something much more surprising. And you are at the center of that story. What do we imagine when we hear Big Bang? A colossal explosion, an incomprehensible force that turned nothing into everything. This idea of a cosmic detonation is attractive, almost cinematic, but it is far from the truth. The Big Bang was not an explosion like the ones we know. There was no fire, shrapnel, or debris flying through space. What happened was much more subtle, but much deeper. Imagine a clock. Not a physical clock, but the concept of time itself. The Big Bang was the first tick of that clock, marking the beginning not of a space, but of space itself. Time. Before that, there was no before, and it was not an isolated event. It happened everywhere at once, including where you are now. Yes, the Big Bang happened in the room where you are sitting. It happened in every atom of your body. It didn't have a center, it didn't have edges, and it definitely wasn't an explosion at a specific point. The universe was smaller, hotter, and denser, and this initial density permeated all. This idea defies logic. How can something happen everywhere at the same time? And how could there not be a before? To understand this, we need to abandon the traditional notion of space and time. Don't think of the universe as a stage on which events occur. Think of the stage itself being built for the first time. The Big Bang was the act of creating the stage, a space where everything could exist. From then on, everything started to expand. Not because something exploded, but because the very fabric of space began to stretch. That expansion is still happening now. Every galaxy, star, and atom is moving away from everyone else. But here's the question. If the universe is expanding, where is it going? The answer is as intriguing as it is disturbing. To nowhere. The universe is not expanding into pre-existing space. It is creating space as it expands. Imagine a balloon being inflated. Space inside the balloon is created as it grows. But unlike the balloon, the universe has no edges. It is infinite even as it grows. And if that wasn't enough to turn our ideas upside down, there's more. The Big Bang was not only the beginning of everything we see, but also everything we don't see. Invisible galaxies, forces we don't yet understand, and perhaps even other universes. But before we get lost in this vastness, we need to confront one basic fact. We don't fully understand the Big Bang. Have you ever heard of the Singularity? It is the idea that at the moment of the Big Bang, all the matter and energy in the universe was compressed into a single point of infinite density. But here's the problem. Infinite density doesn't make sense. Our equations, our physics, everything collapses when we try to describe it. It's like trying to divide by zero. The math just stops working. So if the singularity isn't real, what happened in that first moment? What really started it all? We are faced with a mystery as vast as the universe itself, and science is just beginning to uncover the clues. And here's the big lesson from the Big Bang. It wasn't an isolated event in the distant past. He is a story in progress. The universe is expanding now as you hear these words. Every star you see at night is moving away from you, and the space around you, even here on Earth, is part of that expansion. But this raises an even deeper question. If the Big Bang was the beginning, was he really the start of it all? What if the Big Bang, the most important moment in the history of the universe, was not exactly as we imagined? There is a contradiction at the heart of this story, and it could change everything we know about our origins. Imagine holding a coin in your palm. It looks small, doesn't it? Now, try to visualize the entire universe compressed into something smaller than this coin. Entire galaxies, stars, planets, and even the space where all these things exist, reduced to a single point of infinite density. This is what we call uniqueness. But here's the problem. This idea of infinite density, where everything was compressed into something unimaginably small, completely defies logic. It's as if we were trying to describe the sound of a color or calculate the weight of an idea. It makes no sense, not even to the laws of physics we use to explain the world. The singularity is the point where our equations fail. It is a limit, an abyss in which mathematics stops working. When we look at the universe before this moment, we have no answers, only questions. Questions that lead us to a paradox. How could the entire universe fit into a point that, according to our theories, shouldn't even exist? To understand this dilemma, think about something closer to our daily lives. Imagine a river flowing serenely. Now visualize a waterfall ahead. The river continues calmly until it reaches the edge and then plummets, transforming into a chaotic torrent. The singularity is like the exact point where the water starts to fall. We can't describe exactly what is happening there. We just know that there is a radical change. This lack of understanding is both frustrating and fascinating. It's like being faced with a puzzle where fundamental pieces are missing. And what's even more intriguing is that even though we know a lot about what happened after of the Big Bang, the formation of galaxies, stars, and even ourselves, the initial moment remains a mystery shrouded in uncertainty. But this uncertainty is also an invitation. It forces us to look deeper, to seek answers in the darkest corners of knowledge. That's why scientists over the decades have ventured into bold theories, trying to fill in the gaps left by the idea of singularity. One of these theories is that of cosmic inflation, an idea that tries to explain how the universe made its initial leap from something incredibly small to something as vast as we see today. According to this theory, the universe underwent an exponential expansion, something so fast and so violent that it literally stretched space and time. It's as if we inflated a balloon in fractions of a second, but on a cosmic scale. Now, think about the impact of this on your own life. You are here, listening to this, because billions of years ago, the universe found a way to escape the singularity paradox and expand. Every atom in your body, every beat of your heart, carries a direct connection to that moment. You, in a way, are a manifestation of this expansion. And yet, there are still so many unanswered questions. Perhaps the biggest one is this. If the universe arose from a singularity, something we shouldn't even be able to describe, then what came first? Could it be that there was something before? Or does the very concept of before lose its meaning when we try to understand the beginning of time? These are questions that go far beyond science. They touch us on a deep existential level. After all, if we want to understand where we came from, we need to confront the limits of our own knowledge. And these limits, like the universe, are always expanding. As we continue to explore these mysteries, there is something you can do to continue this journey of discovery. If you feel as intrigued as I do about the universe and our origins, subscribe to the channel, like this video, and share your opinion in the comments. Because this story is still being written and you are part of it. If the Big Bang singularity is not the final answer, what can explain the beginning of the universe? Get ready to explore an idea that has revolutionized our understanding of the cosmos, inflation, and what it reveals may be more surprising than you imagine. Imagine that you are observing a photograph of the universe in its first moments. We don't see galaxies, stars, or planets, just a hot, dense fog, a primal fabric of space and time. How did this turn into the vast cosmos we know today? This transformation is attributed to the theory of cosmic inflation, an idea so radical that it rewrote the foundations of modern cosmology. But what exactly is inflation? Think of a grain of sand. Now imagine this grain being enlarged until it reaches the size of a galaxy, and this happens in an infinitesimal fraction of a second. This was the universe in its first moments, an exponential expansion of unimaginable proportions driven by an unknown force. And here's the most intriguing point. Inflation not only created the universe as we know it, it also resolved fundamental paradoxes. For example, why does the cosmos appear so uniform in all directions? How can a piece of the universe know what is happening billions of light years away? Inflation acts like a cosmic bridge, connecting regions that would otherwise never have interacted. However, inflation raises as many questions as it answers. What caused this accelerated expansion? And perhaps more importantly, what stopped her? Have you ever thought about how precise something needs to be for everything to work? If inflation had lasted a little longer, the universe would be as empty as a bubble. If it had lasted less, it would never have expanded enough to form stars or galaxies. It's like hitting a dartboard thousands of miles away, blindfolded. And that brings us to a fascinating detail: the idea that inflation is not a one-time event, but something that could be happening all the time. Yes, as you are reading this somewhere, new universes may be being created by this same force. This brings us to the concept of multiverse, the possibility that our universe is just one among many. Think about this for a moment. Somewhere there may be a universe where the laws of physics are different, where stars don't form, or where gravity is so weak that everything floats aimlessly. And somewhere else there may be a universe almost identical to ours, but with small differences. Perhaps a version where you made different choices, leading to a completely different life. But how can we be sure of something so strange? The answer is written in the very fabric of the cosmos. Scientists have found indirect evidence of inflation by studying the cosmic microwave background, radiation left over from the Big Bang that fills the universe. Tiny variations in this radiation provide clues about what happened during the earliest moments of existence, like fingerprints of a cosmic crime. However, these fingerprints also hold secrets. They suggest that behind inflation, there is a mysterious force, a quantum field which could be the key to unlocking what came before the Big Bang. And here's the real mystery. If the quantum field that drove inflation still exists, it could be shaping the universe in ways we haven't even imagined yet. Now, stop and think. What if inflation wasn't the beginning? What if there was something before it, something even older, more fundamental? A reality so far from our understanding that it defies the very idea of time? These questions are not just for scientists. They touch on something deeper. Because in seeking to understand the universe, we are, in fact, trying to understand ourselves. After all, we are made of the same particles that appeared in that first instant. We are the distant echo of the Big Bang, exploring its own origins. What if the universe as we know it is not unique? What if there are parallel realities, each with their own laws, histories, and possibilities? What science has discovered could completely transform our view of existence. Imagine yourself walking through a vast field. In front of you are gentle hills, peaceful streams, and expansive plains. Each step reveals a new landscape, a new possibility. Now imagine that this field is not just a place, but a map, a mathematical map that describes all possible universes. Welcome to String Landscape, one of the boldest and most fascinating ideas in modern physics. But to understand why we got here, we need to go back a little. When inflation theory suggested that our universe could be just one of many, it raised a profound question. Why does our universe have exactly the conditions that make life possible? Why do fundamental forces like gravity and electromagnetism have the precise values needed for the formation of stars, planets, and, eventually, you? The answer may lie in extra dimensions predicted by string theory. According to this theory, our universe is not three-dimensional, but has at least 10 dimensions, most of which are folded into scales so small that we cannot perceive them. And the way these dimensions fold determines everything about our cosmos, the particles that exist, the forces that act on them, and even the fundamental constants of nature. Now here's the twist. There are trillions, perhaps infinite, possible ways to fold these extra dimensions. Each of these forms creates a universe with its own rules. Some would be chaotic and uninhabitable, but others could be surprisingly similar to ours. And then the question arises, if there are so many possible universes, why are we in this particular one? This is where the idea of an inflationary multiverse. During inflation, as space expanded rapidly, pieces of the universe could have bubbled out like bubbles, each with its own characteristics. Think of champagne, with bubbles appearing randomly. Each bubble would be a universe, separated from the others by distances so vast that we could never reach them. Now, breathe for a moment. Sound confusing? Let's keep it simple. What science is suggesting is that our universe is just one piece of a much larger puzzle. And this puzzle contains realities so different and bizarre that they challenge our imagination. For example, in another universe, stars might be so massive that they burn up in a matter of seconds. In another, gravity may be so weak that galaxies never form. And in some, physics can be so different that the very idea of matter, as we understand it, doesn't even exist. But how do we know this isn't just science fiction? The answer lies in mathematics. String theory predicts that these bubble universes are not just possible, they are inevitable. And although we cannot travel to these universes, their influences can be inscribed in ours. For example, if a bubble universe collided with ours in the first moments of the Big Bang, it would leave visible marks in the cosmic microwave background, something scientists are actively looking for. Now think about this. What if somewhere there is a copy of you? Perhaps living an almost identical life, but with small differences. A universe where you chose another career, or where a seemingly insignificant decision changed everything. This idea of twin universes is not only fascinating, it makes us reflect on our choices, our destiny, and the role we play in such a vast and uncertain cosmos. But there is an even more disconcerting detail. What if our universe is not the end point of this story? What if it's just a trial, an attempt at a much larger experiment? Some scientists believe that the multiverse is a kind of natural laboratory where all possible combinations of physical laws and constants are tested. And we are here because, as it happens, our universe is one of the rare places where life can emerge. However, this raises a philosophical question. If there are infinite universes, what makes ours special? And most importantly, how can we find meaning in our existence, knowing that we are just a small part of something so immense? The answer may lie in how we choose to look at the cosmos. Maybe we are not special in the cosmic sense, but we are special because we are able to ask these questions. Think about it. You're here now, hearing about infinite universes and extra dimensions. That is a miracle in itself. And that's why the search for answers is not just scientific, it's deeply human. Each theory, each discovery brings us closer to understanding not only the universe, but also our place in it. What if, after all, the universe is not an answer but a question? A question so profound that each discovery only brings us closer to something bigger and more enigmatic. We have reached the limit of what is known. We explore the singularity, inflation, the multiverse, and the string landscape. Each concept took us further, made us imagine beyond time and space, but also confronted us with an inescapable truth. There are limits to what we can understand. And perhaps at the center of this mystery is the nature of the universe itself. Why does it exist? Why is there something instead of nothing? These are questions that transcend science. They lead us to philosophical, spiritual, and deeply personal reflections. And the most intriguing thing is that perhaps the universe does not have a single answer, but an infinite number of them, just as there are infinite universes. Imagine for a moment that the universe is like an infinite book. Each page contains a complete cosmos with its own laws, stories, and mysteries. We, inhabitants of one of these pages, can explore our words, our sentences, perhaps even the entire chapter. But why the book exists and who or what wrote it remains beyond our reach. And here's the most fascinating thing. Maybe we don't need a definitive answer. Perhaps the value of the universe lies in the journey, in the never-ending search for understanding. Think of all the scientific and philosophical revolutions that have shaped our view of the cosmos. Each step has brought us to this moment where we can look up at the sky and not only admire the stars, but also ask questions that no other known living being would be able to imagine. And this connects us in a profound way, because, after all, we are all travelers in this vast sea of possibilities. We are made of the same material that forms stars, galaxies, and, who knows, other universes. When we look at the cosmos, we are, in a way, looking at ourselves. But there is something even more important here. What will we do with this knowledge? Knowing that we are part of something so vast and mysterious should inspire us to take better care of our little corner of the universe. This blue planet, so unique and fragile. It should motivate us to connect with each other, to share our ideas, and to continue searching for answers together. And so, we return to the initial question. What is the Big Bang? It is the beginning of everything we know, but it is also the starting point for infinite possibilities. It's an explosion of questions that continue to shape our existence. As we say goodbye to this journey, I want to leave you with a reflection. The universe is a vast and uncertain place, but you, I, and everyone who shares this curiosity are living proof that we can find meaning in mystery. Each discovery, each idea, brings us closer to understanding not only the cosmos, but also our role within it. If you enjoyed this journey, subscribe to the channel, like this video, and leave a comment. Your voice is an essential part of this exploration. We want to know what you think, what you feel when you look at the universe, because together we are more than observers. We are co-authors of this story. And remember, the universe never stops expanding, and neither does our search for knowledge. Thank you for being with us this far, and don't miss the next video where we continue to explore the greatest mysteries of the cosmos. Because in the end, the biggest question is still out there, waiting to be asked.